She's a senior software engineer at BankWest and have just won Witwa Award last week. Congratulations. So she's actually going to talk about GraphQL. I don't know what it is, and now I'm too afraid to ask. It's like she read my mind, and everybody's here. Anyways, please welcome Rebecca.
Hello. We doing okay after lunch? Yeah. Excellent. So, as Joe said, my name is Rebecca, and I'm here to talk to you about GraphQL. Before we get started, we're doing a quick shout out to the sponsors, because obviously without their input, we would not be here today. In particular, I would like to give a shout out to Microsoft, who are the sponsor for this room in particular. Go Microsoft. Now, if you have any questions, completely fine, but please leave them till the end of the presentation, and we will have a time for Q&A, and also there are notes available online. So feel free to scan the QR code now, or I will put it back up again at the end of the presentation. It's completely your choice. Too late. Now then. My name is Rebecca, like we said, and there are only two things that you need to know about me. One is I do have an intermittent hand tremor. So if you see my hand shaking, it's okay, I'm fine. This is just what they do. All it means is that all of my drinks are shaken, not stirred. The other thing that you need to know is that until recently, I didn't really know what GraphQL was, because after you work in the industry for a while, there's just so many buzzwords and so many new technologies that are emerging all of the time that trying to keep up and keep on top of everything is just not logical and not possible. And all of these technologies, they keep getting really, really hyped. In fact, they get so hyped that you can actually chart it on a hype cycle. So this is by IBM, and it is the hype cycle of emerging technologies. And if you haven't seen this before, very quick run through. We start with the innovation trigger, which is when the new technology is released to the public, is announced to the world. And everyone starts getting really, really excited about it, and it starts getting used more and more and more until we finally hit the peak of inflated expectations. Because this new technology is going to solve every problem ever. And we are going to put it in absolutely everything, and everything will be perfect forever, and we'll never have to do anything again because of this one technology that has saved all our lives. Unfortunately, we very rapidly hit the trough of disillusionment after this, because after a while it becomes apparent that maybe this one singular technology didn't actually fix everything. And maybe it's not appropriate for every scenario and use case. So a lot of people lose a lot of heart at this point, a lot of people will stop using the technology, and things are looking pretty bleak. But then, we hit a slope of enlightenment. Now this is where people pick up the technology again and start exploring and start playing with it again. But this time they're doing it with slightly more realistic expectations. So they know what it can and can't do, and they start figuring out how to use it appropriately. And then from there, after a while, we hit the plateau of productivity. And this is the goal. Because what this means is that your emergent technology has now found its place in the overall technology landscape. It's being used for the scenarios that it was actually designed for in the first place, and everybody wins. Now, the reason I'm talking through all of that is because right now, I think that GraphQL is about here. So we've been through the highs, we've been through the lows, and now we're starting to pick it back up again and starting to use it where it's appropriate to use it. Which is why, if you are someone like myself who kind of missed it the first time around and didn't really pay much attention, it would be a brilliant time to do a refresher and find out what on earth this GraphQL thing is. Which is why we have this talk today. So I'll be going through why this technology is created and what problems it solved. We're going to go through how it works and how it solves that problem. And then we'll go through the basics of getting started with both consuming and creating your own GraphQL APIs. Sound okay? Excellent, I'm seeing a lot of nods. In that case, let's go to figure out why on earth this was created in the first place. Now, I would like you to cast your minds back, all the way back to the distant past of 2012. At the time, there was this social media company, might have heard of them, and Facebook really knew how to build a website. What they didn't know quite as well was how to build an app. So at the time, their app was essentially just an adaptation of the site. And they found it wasn't performing as well compared to competitors' natively built apps. Things weren't looking too great. So they decide they're going to rebuild, and they're going to go native this time. And they've got a lot of existing architecture already, because like the majority of people, they have a lot of REST APIs that they can use and harness for this. And there's nothing wrong with REST. REST is perfect. REST is fine for a lot of scenarios. It is incredibly useful. There's a reason it's so popular. It's great for when you're working with simple data or you're working with static data. Like if you need an API that can retrieve a list of capitals and countries, then it is great for you because that doesn't change quite nearly as often as other data. It also has individual endpoints for all of the available resources, which is brilliant from a separation of concerns point of view. And it can also have stateless operations if you're building something like an API that retrieves the current weather data. By having the self-contained requests, it means that it's very easy to scale out, and it also simplifies your integration with your back-end architecture. And it's also pretty good at linking in with old systems. So on the off chance that you're working with legacy tech, it works really nicely with it. Now, it is great, but it does have its flaws and its own weaknesses. And to go through this, I want you to think about specifically the Facebook example. Imagine that you were building the news feed, and we wanted to do it using REST APIs. So we might have calls for retrieving the list of friends of the logged in user, and then we might have some calls for retrieving the latest statuses of the friends of the logged in user, and then we might have some calls for the comments that are linked to the statuses that are linked to the friends of the logged in user, and then we might have more calls for the replies and the likes of the comments of the statuses of the friends of the logged in user. And pretty quickly you see that we're dealing with a quite complex data scenario. And if you're doing it with REST and all of those calls, you're dealing with an overfetching issue because you're having to retrieve so much additional data, like the full list of friends, just to get the other parts of the information that you do need. And you're sending all of this additional data unnecessarily, which, you know, a bit of a risk. So you really shouldn't be retrieving data unless you plan to use it. You're also, kind of annoyingly, dealing with an underfetching issue because you can't retrieve the information that you need within a single or within a few API calls. You're having to do call after call after call, and that is a lot of traffic. And you have to remember, we're still in 2012 at this point. So your phones at the time are the iPhone 5 and the Samsung Galaxy S3, and they've only got a gig of RAM. So you really, really need to think about your efficiency. Also, all of those endpoints from before that were brilliant for separation of concerns, they require a lot of work. You're constantly having to create new ones for different scenarios or update existing ones and having to maintain all of the previous versions so you don't interrupt an existing client that's already pulling it out. It's just, I mean, it works, but it is a lot of work and it's fairly inefficient for what we're trying to do here. So Facebook thought about this for a while and created GraphQL. Now, the way that GraphQL solves this problem is that it models all of the data into a graph-like structure. So all of the nodes in the graph are various data objects, data points. So they're things like a node could be a user, or it could be a status, or it could be a comment. They're more the things of your data. And then between these nodes, the edges, we have our relationships. And these demonstrate the relationships between each of those pieces of data. So you could have a relationship that is two users being friends, a particular user being the author of a particular status. We can link everything together that way. And because it's all linked, we can traverse across the graph nice and easy. And what that means is you don't have to have a million endpoints anymore. Instead, you can have queries. So you have a single endpoint or a minimal amount of endpoints, depending on how you're building this, and you can just query for exactly the information that you want when you need it. Now this really, really helps with solving the overfetching problem, because now we're no longer sending all of this additional data across and having the risk of having to look after that when we didn't need to, and it is much more efficient. Because you can also have all of this data that we need and get exactly what you want when you want within just one or two requests. And what that means is it is so much better from an efficiency point of view, which is really good if you want to build something that's a bit more real-time, like your live dashboard. It can also handle the evolving requirements fairly easily, because if you need to be able to include a new field or a new variable within it, you can just go ahead and pop it in, and it would have no impact on the existing queries that are already being used, because if they want to use it, they can just adapt their query to do so, but if they don't need it for their scenario, then they just continue on like nothing happened. So it's way easier to handle the maintenance side as well. And also, I quite like how it does error handling. So depending on how you build your GraphQL schema, you can have it so that when it errors and when it gives you your HTTP status code, you can also have it send the partial data that you've created so far and have that as part of your diagnostics for figuring out what caused this particular issue. Now, I'm not saying that we should all go out and use GraphQL for everything ever. There is a reason that REST is still incredibly popular, because it is, quite frankly, suitable for a vast majority of use cases. What I am saying is that if you're working with more complex data, or if you're working with evolving requirements, then GraphQL might be the correct tool for you to use in your scenario. So let's say you have a use case. You want to build a GraphQL API. How do we get started? First, let's look at it from the front-end point of view. Let's go consume ourselves a GraphQL API. To do this manually, you pick yourself your favorite API client. There are plenty of them out there, whether you're going with Postman or Apollo or Insomnia or another one that I've not included on the slide. It doesn't matter which one you go with, they all follow the same sort of structure, which is they will have an area for you to put in the URL for the endpoint that you're going to be querying. They have an area that displays the structure of the schema of the GraphQL API. And the reason it has this so early is because you need to know the structure of the schema to be able to determine the structure of the query itself. And you can retrieve the schema manually if you want to by running an introspective query, but having the client do it automatically is pretty nice. So your structure of your schema is the structure of your query, and also the structure of your query is the structure of your response. So whatever you want to put in is what you will get out in return, unless you want it to be something different. At which point we can do a few things within our queries in order to modify the response that we receive. So let's say, for example, this is a fairly okay structure. We're happy with most of it, but we might have used a different naming convention in the front-end UI. So even though there are two things that both essentially mean the name field, we're using different things and we've called it something else. So we could just send this through as it is and do some post-processing and update it and all of the fun stuff there. Or we could use an alias and have it done as part of the query, saving you that additional processing step. We could also use directives inside these queries in order to implement some basic logic. Now, there are a few default directives, including there's one for include, there's one for skip, which I don't know why it's not called exclude, there's one for deprecate, there's a few of them around. And you can make your own custom ones as well. And what they do is, in this particular scenario, this is essentially an if statement. So if the full details variable is set to true, then we want to include the model field within the response that we receive. So if we have the same API and set full details to false, then we have the query response without the model field. Nice and easy. Now, this one is, it's an okay query, like it's fine, it gets you the information that you want, how you want it. But in the same way that you can break an application down into components, you can break a query down into fragments. So here we've got a bit of duplication happening, just a little bit, mostly because there's not much space on a slide. And we want to extrapolate that out and just have that listed once and then called referentially. Now, if the vehicles and starships objects were both created from an overarching object type of transport, we could do something like this, where we just pull them out, put them in a fragment, and then refer to the fragment as we want. If we want to combine objects of different types, we can always also do that. We can do things like unions. So in this case, we've got a union of the person and planet objects, and if the name value is a person, we'll get the person data back. And if we have the same name value being a planet, we get the planet data back. So there's a lot of adaptability that you can have with the queries in order to get the returned response being exactly the structure that you need for your scenario. But it really, really depends on how you've built your schema. So you can only do the unions if you've got your schema set up to allow it. You can only do the fragments if it's based within the same overarch type. It's all very, very driven by how you design this. So let's swap over to building our GraphQL API. No surprises here. Your schema design is the first thing that you'll want to work on, and your schema is made up of several fairly basic parts. We start with the data structures. So all of the individual objects that you want to make available within this API, all of your things, you can have listed out here. And then based on those data structures, you can have your queries. And these are the ways in which you will allow front-end clients to call to retrieve data from your API. You can also have mutations, which are very similar to queries, but this time you're allowing people to modify APIs or to add data to your data sources. And then finally, we can also have subscriptions, which, to be honest, is essentially just keeping open a WebSocket connection. But what it does is it allows you to be alerted if there's any external changes to your data source's data. Now you pop that all together and you have yourself a schema. Nice. So then we get to the other half of the building, which is we build our resolvers. Now a resolver, much like the name suggests, it resolves things. In particular, it resolves individual fields and links. This is the part where you are linking to your data source and retrieving the information as required. Now, your data source can be anything. You could be going to a various number of databases, you could be going to another API, you could be going to a random text file on your machine. It does not care. It's quite happy to resolve from wherever you need it to. And the resolver functions have a very particular set of parameters that we need. So we've got 4 parameters: parents, args, context, and info. Now, parent is actually the result of the execution of the previous resolver. So yes, if it's the first resolver that's run, that is null. And the reason that we have that result is because we need to use it in two different ways. So first, we need to be able to keep track of what data goes where when we have the results of all of the resolvers functions, so that we can serialize them into a single file, which is usually JSON, and return that to the front-end client as the response. We can also use the parent as a data source. So say this query returns this book object, and then the next resolver that runs is for retrieving the author details. Because the parent parameter in this scenario is that book object, we can refer to the author ID within it and use it as a data source for retrieving our next set of information. Make sense? Excellent, got some nods. So that's parent. Then we have args, which you'll never believe this, it's short for arguments. And these are the arguments that were within your original query in the first place that you can use for including inside logic as needed. Then there's context, which these are your more global pieces of information. This is the same regardless of your resolver. And this is everything that it would need that is, well, contextual. So your authentication information for the user is always going to be the same. Or if you know that you're going to be connecting to particular databases and you just want to share the connection details more globally, this is also where that would be. And then finally you have info, which is your nice to have, additional, optional, etc. This is a great place for you to put any additional information, whether you want to do the path from root so that you can have it there for setting a caching policy at the resolver level, or just anything you like, really. And honestly, that is basically your resolver in a nutshell. So at this point, people start going, okay, so if you're letting all of the users do all of their queries on all of the parameters on a single endpoint or a minimum amount of endpoints, how does security work? And the cop-out answer is it works how you build it, in that there is a quite large number of ways and it's quite flexible and you can do what's useful for your scenario. For an actual answer, for authentication, I would recommend intercepting the requests before they get to the resolvers using middleware, and there are a number of standard libraries that will enable you to do that. So like Express JWT is one that shockingly is quite good at helping you validate your JSON web tokens, and you can authenticate your users that way. For your authorization, you can do any kind of logic you like. You can go role-based, you can go attribute-based, you can write your own logic. GraphQL does not care. All that I would recommend is that you abstract it outside of the resolvers and just have them call the authorization logic as needed so that you can have it all in the same place. But by applying it here, you get that greater level of granularity because you can apply it on a field-by-field level. And again, there are standard libraries for that, like GraphQL Shield. Now, GraphQL will let you do a lot of things, and sometimes it will let you do too much. It will give you a bit too much flexibility. And out of the box, you can put yourself at risk of a denial of service attack by having an overly complex query that exhausts all of your resources. So, for example, this is technically a valid query. It's a little recursive, but it will try to execute depending on the API, and if it's able to resolve, it will quite happily give you the JSON back in the same format. But you can see how with that level of complexity and that level of recursion, you could really crash and break everything quite easily. So we want to maybe consider not letting that happen. And there are a few different ways we can do this. We could have a threshold for the level of complexity that we are willing to accept for an input. And again, there are standard libraries, and again, they are called very obvious names like GraphQL Query Complexity Library to allow you to set that threshold easily, or you could limit things by depth, so you can choose how deep you're going to allow this query to be nested and prevent it being too complicated that way. Or you could do your rate limiting, or your pagination, or your caching, or any of your other more standard approaches that you would take to handling things in your REST APIs also apply to your GraphQL API. And then once you've got everything built, it's up and running, you might want to keep an eye on it. And there are observability tools available out there. There's GraphQL, there's Apollo Studio, and again, they're all fairly standard and they all have fairly similar features, and they will let you quite easily keep track of your logs and your matrices, and you're doing your traces in a nice, convenient format. So now that we know how to build a GraphQL API, surely all we want to do now is keep building more and more of them, right? Just keep going and keep building all of the GraphQL APIs forever. If you're doing that, what I would recommend is that you can actually integrate them together into using GraphQL Federation and have a unified API. And as an example of this, if you think of the Star Wars API, you could have one single overarching schema that has all of the data structures and all of the data that you need in it. Or you could have a subservice that's for the characters. Maybe you'll have one for planets. You could have another one for the films. And then you can integrate them all together in an API gateway. And it will still look like a single GraphQL API to your front-end clients. And what this allows you to do is you can work on each of these subgraphs and not worry about impacting the rest of the system. So you can scale them individually, or you can do whatever you like, and it's just a lot more modular and easy to maintain from a maintenance perspective. If you get too many APIs going, or too many subgraphs going, or if you get too complex because you've gone mad with power and you're creating all of these things, you can start having performance issues in the same way that you would have performance issues with anything after you overloaded it and built it and did all these cool things. And for this, Facebook has again created another thing. So data loader is a way of having your API calls batched and cached. So instead of having multiple calls to a particular data source for each of the individual resolvers and going open connection, get it, close, instead of doing that, you can batch it all together and do a single connection, get the data you need, and get out. So it tidies things up quite nicely there. And it also keeps the returned data in cache, so that if you need it for any additional steps or any resolvers that are executing later on, they can retrieve it from there as a data source rather than making the call out again. Now, because we can't have a talk without AI, yes, you can stick AI in GraphQL. There are a few different ways that you could do this. You could use an AI API as a data source, or you could actually integrate AI into the building of your queries and your APIs in the first place. So GQLPT exists. And if you would like to, instead of structuring your own very simple query in the declarative language that's easy to use, you can just put in your question in natural language and have it generated for you. So GraphQL is a useful tool. Today we've learned that it was created because we needed to deal with a complex data scenario, and it handles that quite nicely. We know that if we're working with evolving data requirements, that again, it can be the right tool for the job. We've looked at how you consume it and how you structure your queries so that you can get the data sources as need be. And then we've looked a bit into building our GraphQL APIs including the security and the observability and everything to keep in mind for a successful GraphQL API to be created. And then we've created a whole load more and federated them, which is pretty fun. So with that, thank you all for listening. Here is the QR code again, and are there any questions?
Hi.
Hi.
Do you have any use cases for GraphQL that you've done at Bankwest?
I can, but I'm not allowed to talk about them.
Okay, that was my question.
Yeah, so for REST, you obviously have like post-patch updates and creates. Is there any analog with GraphQL?
In short, yes. In long, also yes. Yeah.
Yep, I'm walking.
So a question about access pattern design. In GraphQL, obviously, you can design your access patterns however you want, and it's very flexible. When you go to optimize those access patterns, how do you deal with that? Like if I've got a certain access pattern defined in a REST API, I can add an index to the database. Whereas in GraphQL, how do you account for that unknown of the access pattern?
I think I'm going to have to think about that and get back to you. I'm not sure, apart from a more standard answer of you just keep testing and keep trying and keep doing. But I don't have any specific answer for that. Sorry.
Just wondering how does GraphQL handle like retries and other resilience kind of operations?
Yes, you can put in retries in there, and you can, any of your more async or retrying things can be built in the same way that you would build it for any other API. Do we have any more questions? Oh, we've got one down the front.
Thank you. Just one thing, or two things to mention. I think one of the best benefits of the GraphQL that I could see was the self-documentation.
Yes.
Which wasn't mentioned. The thing I didn't understand was the resolvers. So you mentioned query, mutations, and subscriptions. What with the resolver, you had the resolver inside the query. Is that? I didn't quite understand how that worked.
Okay, yeah. So first of all, yes, excellent shout out about the self-documentation. I had forgotten to mention that, and it is quite useful, but you literally cannot have a GraphQL API that isn't documented. Score. With the resolvers, the way that it works is in your schema, you've defined particular queries that you're allowing it to use. So if you have a Star Wars API and you're allowing it to query based on character, then you have a list of essentially you can do character queries in the schema. And then in the resolver function is working for all of the available queries. When we are allowing them to search by character, then we are returning this resource for this character function. And then, so if you were retrieving your character information, you'll be pulling from this resolver. If you wanted to update a character, then it would be a different area of the resolver file, which would be under the mutations, which would be the character update mutation, and then you would have a different resolver for applying that update logic. Does that make more sense? Okay, cool. Thanks. Any more questions?
No, we are ready to go.
Awesome.
Oh, one more.
Can we wait for the microphone, please? I cannot hear you at all, I'm sorry.
Sorry. In terms of just adapting GraphQL APIs, are there any advantages of just remaining with REST APIs?
Sure. So GraphQL is great for complex data, but it's also a bit more complex to set up in the first place. So if you don't need the functionality that GraphQL provides, if you can get the information you need quite easily through a REST API, then use a REST API. Like, you don't need to go overkill on it just because it's a cool tech to work with. It's more just, it's a tool that you can use depending on the scenario. No worries.
In your experience, have you ever migrated a REST API to a GraphQL API? And if so, or if not, can you think of any kind of pitfalls that you'd need to keep in mind?
So I haven't done it personally, so I am very much winging this now. If people are used to working with the individual endpoints and they're used to structuring things, like if they're used to having the security based on the endpoint or just used to having that separation of concerns, you could have a pitfall where you're not setting up your authentication and authorization properly for the new GraphQL API because they would be thinking endpoint rather than variable. So that might be something that I would be more worried about if I was doing that transformation. Thank you. Going once, going twice. All right, cool. Thank you very much.
Thank you, Rebecca.